Okay, now that you've seen number 5, I would definitely suggest that you try this one on your own first before you watch this video, just to see that you got it. But now, since you're here right now, might as well go through the answer, right? Okay, so for this one, it's very similar to numbers 5. The only difference is a little bit of the algebra. So in part A, those of you that did try this, most of you avoided this because I think you got a little bit scared with the algebra. But you do set this equal to 0. And so the natural log of x squared is equal to -2. Here, the inverse of the natural log is e. So e to the natural log of x squared is equal to e to the -2. And so here we get that x squared is 1 over e squared. So that x is plus or minus the square root of 1 over e squared, or the square root of 1 over e. So those are your critical points, 2 critical points. And so then you create your number line. One of the critical values is 1 over e. One of the critical values is -1 over e. You can go ahead and go to Desmos to see 1 over e is, or sorry, a calculator. So this is about plus or minus 0.368. Okay. So the reason I always do that part is I want to make sure that I know what to pick, what numbers to pick. So definitely 0 would be a good number, but I can pick 1 and I can pick -1. And so when you plug these in, actually 0 is a problem. 0 is undefined. And so then that tells me that, I should probably pick. So 0 ends up being a critical number, it's undefined. So maybe I should pick x equals 1/4 and x equals -1/4. All right, so then you plug this into the derivative. So g prime of -1 is equal to 2 plus the natural log of -1 squared, which is just 1. The natural log of 1 is 0, so this is just 2. This is positive. G prime of -1/4 is 2 plus natural log of -1/4 squared, but that's just 2 plus natural log of 1/16, which is very, very negative. In fact, again, you use your calculator for this part, but 2 plus the natural log of 1/16 is -0.77. So negative, 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 negative. Whereas if I do g prime of 1/4, let's see what happens here. So it's 2 plus natural log of 1/4 squared. Oh, wait a minute, that's just 2 plus natural log of 1/16. So it's the same thing, negative, 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 negative. But there's something going on here. And I'll explain what happens there really quickly. And then the g prime of 1 is 2 plus natural log of 1, which is again 2. So positive, 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 positive. Now, g prime of 0 is undefined because you get 2 plus natural log of 0 squared. That's undefined. They already told me that x equals, it cannot be 0. So that automatically becomes a point of interest. That automatically is either an asymptote or something else is going on. And in this case, it turns out that it's something else going on. It's not actually quite an asymptote. But it doesn't mean you can't do the analysis. So just looking at this, you can tell that this is a local max because it goes up and then comes down. And you can tell this is a local min because it goes down and then it goes up. So you could say something as follows, based on the chart. G increases on the intervals -infinity to -1 over e and 1 over e to infinity, and decreases on -1 over e to 0 and 0 to 1 over e. So here, what I was checking for is, do you understand what I mean by domain? This is, again, a skill from pre-calculus, and it helps me see where you're at. And if you don't understand, then at least I know I need to do some work. Okay, and obviously I need to do some work. That's why I'm doing this video. So thus, thus f of -1 over e is a local max. And it's supposed to be g. Sorry, I don't know where I put f. And g of 1 over e is a local min. And like I said, you can leave it like this if you're running out of time. You're already investing a lot of time in this problem, so that would be an appropriate place to leave this question. All right, for the second part, let's do concavity. So it almost looks, you can probably guess that it's going to be concave down and concave up, but let's do part B. So one of the reasons I like part B is that it already gives you the second derivative as 2 over x. So you can already see that the critical number here is x equals 0. So the number chart for this case, g double prime, there's the 0. You pick, let's say, something like x equals 1. This one's an easy one to do in your head. You plug x equals 1 and you see that gives you positives. And then you plug in x equals -1 and you see that gives you negatives. And so now if you can do that quickly, that's great. That's why I picked this one, but based on the number chart or on the line chart, G is concave up. Let's start with concave down. Concave down on -infinity to 0, and concave up on 0 to infinity. Okay, so far, based on my analysis, right? So now I got to do part C. Based on my analysis, I feel like there's some things I got, and there's some things I'm not quite sure of. So let me explain. So remember, these are sketches. These don't have to be perfect. But the first thing I sort of understand is that 1 over e and -1 over e are important, and that so 1 over e is, let's say, right here, and -1 over e is right here. So they're about 3.68. And I know one of them is a local max, and I don't, so this is the local max, whatever the output is, but I also know that it's concave, sorry, it's a local min. Right, it's a local min, and it's concave up. So I don't know if it's over here, or over here, or where. So here's where I might want to plug in g of 1 over e and see what I get. So this is 2 plus natural log of 1 over e squared. So here again, you use your calculator just to make sure that you got this right. So what is, sorry, not plus. I don't know what I'm thinking. I'm plugging it into the wrong one. G of x is x natural log of x squared. So I should plug it into there. So I'm doing this. And here's where I probably use my calculator. And according to my calculator, this is approximately -0.736. So now at least that tells me, okay, it looks something as so. So there's a min, and then there's something like that looks like this. And here, what I can do next is I can do the same thing on the right, but if I want to make my life a little easier, I should probably read the rest of what I've got. Notice that it has symmetry about the origin. That means I don't have to look at the right, okay? I know it's all real numbers except x equals 0. Oh, there's two intercepts, 1, 0, and -1, 0. That's good to know. So if this is 1 over e, if you remember, is approximately 0.368. So that means one of the points where it has a, let's say it's over here. This is maybe 1, 0. So my graph is probably going to go hit that one. Okay. And then I asked myself, are there any asymptotes? And it says, nope, no asymptotes. So I'm pretty sure that here it's going to do something like this. It's just going to go. And then I just need to know what happens on the other side. The function, it says there are no y-intercepts, but notice that the limit as x goes to 0 is equal to 0. So again, this is undefined, but they're telling me there's a limit. And so that means this is true. And because there's symmetry, That means this is true. And again, there's the local max. It's concave down, it's concave up, and there's the local min. And my best guess at the moment would be that this is the answer, looks something like this. And sure enough, there's only one thing I got kind of incorrect, but that's because I didn't ask you to analyze that part. But this is the actual graph. And the only thing that's a little weird is that here, if you notice this piece, it almost looks like the slope is straight up and down. And of course, we haven't talked too much about that. That's sort of an issue in calculus that we might want to discuss in the last week's class. But otherwise, if you had given me something like this, that would have been perfect because it puts all the things together. So again, I hope this helps you, and good luck studying for this next assessment.